and I will start with the adhesive coating at the beginning. So there are two crucial points we have to take into account. The one is, and both are from what is called Industrial Emission Directive. We have the chapter 5, that is the former Solvent Emissions Directive from 1999, as Elena has told you. That has been included in this Industrial Emission Directive. And here you will find a different number in the Annex 1. That are installations for surface treatment, where on an industrial scale, where a solvent consumption threshold of more of 150 kilograms per hour or more than 200 tons per year is exceeded. Please take into account this is referring on the capacity that is a maximum possible. That means that is installed and that could be used. If it's used, doesn't matter. Only the installed capacity here is relevant. That's different to that chapter 5. Here, that solvent consumption threshold with 5 tons for adhesive coating is an annual quantity. So maybe in 1 year you can exceed that quantity, in the other year you're below. And so that is a fluctuating value. I just only want to say that we in Germany, because such type of installations have some environmental problems, we have the requirement for environmental permitting, very similar to that IPPC permit, and that threshold starts with here 15 tons per year. So that gives us a chance to establish a permit like here for the large installations, and where we can regulate such installations very good. Yes, so the first question is, what is adhesive coating? So there's a definition that is an activity where adhesive is applied to a surface. And there's an exception, but later I will explain you more. If this is done in kind of in very close context with printing, then we speak about associated adhesive coating or lamination, and that will be regulated under the printing activity, and it's not an individual activity adhesive coating. So important to notice, we have to take into account all of the VOC quantities that are used for this activity, especially the VOC content from agents used for cleaning of the equipment. So that's really important, because that's maybe a large quantity of VOC. Now, what is an adhesive? So here we find a definition too. That is any mixture. It's very important, including all organic solvents. So you see, important is adhesive is a mixture necessary, which is used to adhere separate parts of a product. So if you glue something together, you have 2 parts and you glue it together. So that is, and you use an agent for that. So that is a glue or adhesive under that definition. And that adhesive can have organic solvents. Can have, because here, for example, hot melts are an adhesive too. And for example, if you have an installation where you use hot melts that are 100%, let me say, solids and don't have volatile organic compounds. So you can use them for the reduction scheme for the quantity of solids, but I will explain you later. Here, there's a different definition, but generally, of course, it is very similar. So, what is an installation? So here, that is a stationary technical unit where such an activity or other activities are carried out. Important, if you have such a technical unit, for example, for the production of polyurethane or plastics, doesn't matter. So in such an installation, you could carry out different VOC activities under the VOC Serbian decree. And now it is important to identify the different VOC activities, because for all of them, you have to determine the solvent consumption. So you cannot do a addition on all VOC, consumed VOCs to add together. No, you have really to identify the individual VOC activities, and for them, you have to do then a solvent mass balance, and you have to calculate the solvent consumption for each of the identified VOC activities. Here's an example. You have one site, that's important. If you have, for example, different sites, so you are one operator, but you have maybe in village one, you have one site and you have another site in another village. So no, that is not added together. So we have to then to do a separate consideration. But if we have one site, operation site with same operator, and here we have the production of a product A and the product B, maybe in two separate halls. And for the product A, you do your additive by yourself. That means you buy some ingredients and you mix and produce your additive because it's a spatial one. That is an activity that is called manufacturing of adhesives. And later, in the next step, you use that adhesive to adhere two parts together. So we would have the activity adhesive coating. And in the other hall, in the other fabric hall, you have maybe first the cleaning of the produced product. Maybe you're using organic solvents for that product cleaning. And then later you have here the metal to do a metal coating. So what if you look now in detail? So we have here one installation where we have 4 VOC activities. If you look in the VOC decree, we would have the manufacturing of adhesive, the adhesive coating, the service or product cleaning, and metal coating. Now, what we have to do, we have, of course, to check now the solvent consumption threshold, because each of the listed activities in the VOC decree has an individual VOC consumption threshold. Only if that threshold is exceeded, then that activity will be under the scope of the VOC decree. So let me give you an example. Maybe, for example, the metal coating unit where the threshold is 5 tons has only maybe 3 tons. So that metal coating unit would not be under the scope of the VOC decree. So that is something and that's the first task you have, or we all have, to check the activities that are existing in an installation. That's the first thing we have to do, and that can be rather tricky. Here, for example, what is very common, you have unsaturated polyester resins. You know, there is styrene as a solvent inside, but styrene is not only a solvent in the meaning to adjust the viscosity. It is a monomer for the reaction when that resin will be hard. In other words, there takes place a polymerization, and later on we have produced that plastic. So here, as an example, you have metal form. Then you have to put on a release agent. In that release agent, generally they are VOCs. So what you're doing, you're coating a metal. Even it's temporary, but it doesn't matter if it's temporary or not. The important thing is you do a layer on a set metal form, and even we know that it's only a temporary thing, you do that coating, and if you use VOC containing release agent, then we have to take into account the VOC content of that release agent for the activity metal coating. So the next thing what you're doing, you do what's called gel coating. That is a spraying process. That's the first layer you produce. Yes, and then that is the same. You coat that metal form. Now you do a kind of what is called lamination. It's a manual lamination process. That means you put one layer with glass fibers together with a glue. That's UP resin, and so you put one layer on the other of this glass fibers, and it's a wet process generally. So you glue finally the mats of glass fibers together, so that you will receive at the end a hard composite. So if we do that as an example, here the first thing is clear. For the we have two VOC activities. So one is that gel coating, and of course here we have to, it's a metal coating. So we have an activity metal coating, and we have to check if the VOC threshold of 5 tons will be exceeded by the quantities that are used for the release agent, for the gel coating, and for the cleaning, for that activities. Then we have a separate activity that is the adhesive coating. So here it's important, what is now the solvent? What is the VOC content what we have to use? Because we have a special case. Most of the styrene will be will be a solid. So that part that will be a solid, we will not take into account for our VOC calculation. So for example, we use the gel coat input, and then we multiply it with the styrene emission losses. There are some tables published, for example, by the European Association. Here, for example, 14%. So we know that the VOC that will be emitted, for example, in this case, are 3 tons. So we have to calculate now the VOC for the cleaning operations, because it's acetone. It's here a large quantity, so 5 tons. And we have that release agent to take into account here too. So that is 1 ton. So at the end, we will exceed that 5 tons for the adhesive coating. And so both activities would be under the scope. So that is for the manual lamination. It's here the same, but here the emissions are only 6%. So we have here 17 tons for the cleaning, and finally we have here 20 tons for the adhesive coating. So we see that adhesive coating will be under the scope too. So both activities, as I showed you here, that means first the coating of the metal by the release agent and the first layer, the gel coating, and here then the manual lamination that would be considered as adhesive coating. So for both, we have requirements given in the VOC decree. Here, maybe we have one operator, one site. We have 2 standalone installations. There are no connecting parts. And in one installation, you have different adhesive coating lines. You have maybe one unit in that installation where you do a cleaning of the product by using solvents. And in another installation, you produce another product. It's a separate unit. So it's the same. You would have 2 VOC activities, one for the product surface cleaning, and here in the same color, you have to add all VOC contents of all of the 4 units together, and because they will be covered under the adhesive coating activity. So now from practical points of view, as I have told you already, but it's very important. We're in that VOC decree, we will find under the VOC activities, the activity printing. And here, if you have a lamination that is, let me say, in line with the printing activity, that is associated with the printing activity, that lamination and varnishing is not covered by the VOC activity lamination, wood plastic lamination. Neither it is under the scope of the activity adhesive coating. It is here in line with the printing unit, and so we have to we have to deal under the printing activity with such a lamination process. Another point, footwear manufacture. We had already a training for footwear manufacture. There is a problem. The limit value for the footwear manufacturer is addressed to the complete pair of shoes. So if relevant parts are produced in a separate company, for example, some parts of a sole are glued together, and that composite sole is then sold to the footwear manufacturer who is producing the whole pair of shoes. it is not possible for the producer of the sole composite to use the total emission limit value for the footwear manufacturer, because that operator is not producing the whole pair of shoes. So if you produce only parts of shoes and you glue them together to a composite, then you will not fall under the footwear manufacturer activity. You are typical adhesive coater. So that is a better activity, because you can't use the emission limit value for the whole pair of shoes. Yes, and that is what we speak today. There's another activity, it's called wood plastic lamination. That is the lamination of wood, or wood plastic, or plastic and plastic. So that is generally only relevant if you produce layers. That means webs and areas, foils. So that is important to take into account, that here really the lamination of webs are addressed. Okay, so important too, if you produce adhesives, so that is not generally a part of the adhesive coating activity. Generally, it is a separate activity with, of course, different solvent thresholds. That means if you really produce your adhesive, that means from all the different ingredients. But if you do only, for example, a thinning, or or a thinning of adhesive, so you're not doing the production of an adhesive, that VOC that you're using then, and it's included in the adhesive, of course, you have to take into account when you do the solvent mass balance for the activity adhesive coating. If you use, for example, adhesives for materials like paper or metals, that we would consider as adhesive coating too. For example, when you're producing tapes, you have a composite of different layers of different materials. That would be a typical adhesive coating process too. I spoke already, but it's important to point out again. Don't look only on that chapter 5 or VOC decree. If you are operating a large industrial VOC or service treatment installation, then you must look on that IED Annex 1, number 6.7, because here you see that activity is not only including as a separate activity adhesive coating. Here, generally, there are all service treatment that you're doing on your site will be covered and compared with the organic soil consumption capacity. So, for example, if you do several surface treatments, all of the VOC consumption capacity will be added together. That is important to keep in mind. Typical installation is the production of adhesive tapes, because that are produced in a large quantity and very often set thresholds of 200 tons per year are exceeded. what I want to say, there are so-called best available techniques for that large industrial emission directive installations. Later on, I will show some best available techniques, because the application of the best available techniques associated emission levels, BRT-RELs, they have to be applied for such big installations. By the way, I was a member of the, or I'm a member of that European technical working group, where we have revised that best available techniques document. So I was a representative from Germany, from our side of authority. Yes, now let's speak about the requirements. So here it's very important to keep that scheme in mind. First, you must identify all the VOC activities that one operator on one side is carrying out. If you don't find some, yes, you can be happy, then you are not under the chapter 5 or you are not under the VOC decree. If you have identified an VOC activity, then you must check the solvent consumption. There's a formula how to do it. Generally, it is identical with solvent input. That means all VOC containing materials that you have purchased and have been used in a 12-month period, in, let me say, from 1st January to end of December. And if you exceed the given threshold, then you know that activity will be under the scope of the chapter 5 or VOC decree. Now, Elena has already explained to you some requirements. I only want to use the chance to point out there are some critical substances like CMRs, and that must be substituted. And if it's not possible to substitute them, you must comply to a low VOC emission mass concentration in the stacks if a mass flow of 10 grams per hour is exceeded. Here, that is the total. That means if you have several CMRs in your waste gas, then that is the sum. You must, the total must comply with that emission limit value. And there are requirements for volatile halogenated VOCs like methylene chloride. And important to keep in mind is, in Serbia, you have so-called class 1 substances like toluene or xylene. So for such materials, the total may not exceed 20 milligram per cubic meter in the stack emissions. Very important is because in practice, some people have a misunderstanding. Here, that means general requirements, so that conditions for CMR and volatile halogenated VOCs and so on, that are always valid. They have a higher priority as specific requirements for the individual activities. So to that general requirements, all have to comply with. So that is important to keep in mind too. You can, you know, how you can identify such CMR materials, and please keep in mind too, we speak only about the volatile organic cancerogenic or CMR materials, and not on inorganic materials like chrome. That's important to have in mind too. Yes, so that you can look by yourself. Important is that substitution rule. It is not only that you have to check one time. That substitution rule is always valid. That means even in the moment you're not able to substitute the CMRs, but you have to check it regularly and to prove to your authority if a substitution is possible. So it's a permanent obligation, and it's not only checked one time. If you deal with such hazardous compounds, you must be aware, you must work in a contained condition. In other words, if you work in open workspaces, it is not possible to do that with such critical compounds. Here now we come to the specific requirements. As you have heard, there are generally two alternatives. The one is the compliance with the emission limit values, and the other alternative is the use of low VOC materials, and that is called reduction scheme. The name is stupid, but you can just say this alternative is really the use of primary measures. In other words, the use of, you don't use a voice gas abatement, you use low VOC materials where you achieve the same reduction as you would operate a voice gas abatement. And you see that's the reason I made it like here. For the adhesive coating, we have stack emission limits, and we have additional, both must be complied with, emission limit values for fugitive emissions. And here, to determine the fugitive emission values, we must use something that is called solvent mass balance. That's the same for the reduction scheme. You will see. Now, specialty for the large installations that fall under this 6.7 Annex 1 of IED, the so-called IPPC installations, like adhesive tapes. Here, for adhesive tapes, you have a total emission limit value. And as an alternative, you can comply with the limit value for the waste gas, for the stack emissions, and for fugitive emissions. So that is possible for the large installations. I only want to say, normally I like very much the total emission limit values, but here you must take into account that's an annual value. So it's possible that in short times you can have high emissions if you compensate later on that emissions. And in that time where you have very high emissions, you can have impacts to the environment, like odor problems with the neighbors. And that can be yes, a big problem. So in Germany, we do not accept only a total emission limit value. We set additional emission limit values for the stacks. Here you see an example now. You see we have two classes. Class 1, that is where 5 tons are exceeded. You see the requirements for fugitive emission limit is not so high as if you exceed 15 tons. And now, very important, stack emissions that are not connected to a waste gas, VOC waste gas abatement, we consider as here fugitive emissions. In other words, if you have an installation where you have the release by a stack, but without any abatement for the VOCs, that quantities will be considered as fugitive emissions. And you see that's very often in the VOC decree, the limit value for the fugitive emissions are calculated as a percentage of the total solvent input. You see, it is an annual value. So the limit value is an annual limit value, depending on the solvent input. It's not a static value. And if you have no waste gas abatement, that means almost all VOC quantities that you're using will be emitted. Doesn't matter where, but they will be emitted. So there is no reduction. And the target of that VOC decree is to improve the emission situation, to reduce the VOCs that are released to the atmosphere, to achieve a better air quality. I mean, that's the final goal. So if you have almost 100% VOC released to the atmosphere, where do you have a reduction? Where do you have an improvement? You don't have. You don't change the system. So it is clear, to achieve a reduction, it is only possible if somebody is doing something. That means you reduce the VOC emissions by changing to low VOC materials, or you install a waste gas abatement where you destroy the VOC from the stacks, or you collect them and you reuse them, or what else. But to improve the situation for the environment, you must do somehow a reduction. So that's the reason. If you have no abatement, you will have almost 100% fugitive emissions, and that will force the operators to do a decision to comply with that limit values, but then you must collect all of the VOC, or almost all of the VOC gases directly at the source of origin. That means where the VOC emissions are coming out. And you must feed them to an appropriate VOC abatement system. So if you do like that, your fugitive emissions will be very low for sure, because you collect everywhere all the VOCs and you clean the waste gas. Or you change to low VOC materials and you achieve the same effect. Yes, here you see the different situations. You see, for example, emission source, that's abatement, and here we have the stack emissions. So that we call 011. Or you have, you collect all the operation hall air and you clean it in, by abatement. So after that cleaning, you have the same effect. You have a cleaned captured waste gas 011. Here, that is exactly the case we have now spoken before. You have a machine, you extract the waste VOCs, but you discharge them to the atmosphere. You see, there is no reduction effect for the environment. You will not achieve a better air quality, because it doesn't matter if the VOCs will get out finally here by windows or in other fugitive ways, or they extract it and discharge directly to the atmosphere. There's no material effect. So that differentiation is for all coating installations is similar. Now, the idea of a reduction scheme. The name, as I told you, is a little bit complicated. It is because when the Solvent Emissions Directive started in 1999, we had a lot of existing installations on a high level. And that installation, of course, they had to think about how they can reduce their emission situation. And that this was then the name reduction scheme, to have a plan to reduce your VOC situation. So at the end, you must improve the situation and to achieve a reduction by using low VOC materials. So that's here at the end. That's your final goal. So the first is you need what is called the annual reference emission. It is, how can I say, it's a fictive starting point that where we go back to the year 1909. So we play as if we would be in that year. That means we have to determine the quantities of and mass of solids, and we have to look to a table that is listed in the VOC decree, and we find a multiplication factor, and that multiplication factor we use and multiply the total mass of solids, and then we will get maybe the situation of VOC emissions from the year 1999. So it's like a starting point. Why this system? Because, you know, the solid, that is what remains. The other is the volatile of a coating or of an adhesive that will evaporate. So that solid finally will glue together the two parts. So that's the reason the total mass of solid is relevant for maybe the strength of the adhesive glued together parts. And so it makes sense to do that calculation step. Because finally, for the functional, for the function and for that mass is relevant, and not that mass of volatiles. So when we have done that, we look again in the VOC decree. There's another table. There we find what is called reduction percentage. And that percentage is depending on, let me say, the class of installation. If you have a larger or smaller installation. Yes, and here for adhesive coating, you see if we are in the lower range, threshold range, we have 25, that's the fugitive emission limit value, plus 5, and 20 plus 5 for the larger one. Yes, so we do that calculation. And finally, so it's done like here. If our real emission is the same or hopefully less, then the calculated what's called target emission, then we are in compliance with. Please take care on the name target value. That target value is is wrong. It's not a target, so something like in the meaning, oh, it is nice if we can achieve our goal. For example, if I do a hiking tour and I want to hike 40 kilometers, but maybe 10 kilometers before I find a nice restaurant and I say, oh, it's better I stay here. No, that's not, that target value is an emission limit value. You must get this value. And not like my hiking tour where maybe I can rest, stay at that restaurant, and the last 10 kilometers I will not walk anymore. But here we have to comply with that target value. It has the same meaning like an emission limit value for the stack emissions. So yes, so you see here again the formula. You must determine the total mass of solids of the materials. You look very simple to the table, and you multiply it with then the percentage that you find in the table too. Here I did already this total factor calculation. So if you multiply your total mass solids with 1.2 or with 1, you receive your so-called target values. Yes, you must calculate set reference emission and target emissions annually. That target emission is an annual value, so every year you must calculate it new. So if you have already done some activities to reduce your VOCs, you cannot, how can I say, it is not a bonus in that way. The calculation method is always the same. So probably it will help you to comply with, but you don't get any bonus because you have done already something before. So as told you before, that was the reason I pronounced that what is an adhesive very much. In adhesive coating nowadays, very often you find, for example, 100% materials or hot melts. That means you have a process. For example, you have 3 lines and you have problems. So in one line, you were able to reduce the VOC by changing to hot melt. And that hot melt has no VOC. As I told you before, you would take into account all the quantities of the solid for all 3 coating lines. And in other words, for if you do a reduction scheme, you can then use that quantity of the hot melt to 100% because you don't have VOC as for the calculation of the solids. So that will help you maybe for compliance for the whole installation. Yes, we have a nice system for smaller installations that here are in the lower range. It is called a simplified verification of such a reduction scheme. The benefit is the operator submits a declaration that I only want to use such coating materials with a given limited VOC content. And so, yes, the authority can accept this declaration. And so for the operators, the benefit is the things are going much more simple. No annual solvent mass balance must be elaborated and so on. So it's a very simple procedure. But of course, that means that obligation or the confirmation is referred on that obligation, that you use only adhesives and primers that have less than 5% VOC content. So what is an organic solvent? Organic solvent is a complex term because it is not only in the meaning of a classic way that you have a substance, a solvent that dissolves another substance. No, here it is a very comprehensive meaning. It includes plasticizers, preservative, viscosity adjuster, so dispersion medias, dissolvers. So really a lot of yes, applications. And of course, it must be always volatile. So the term volatile is defined in the VOC degree 2. It's a substance with a vapor pressure of 0.01 kilopascal. And now very tricky. For example, if you have a dryer where you use higher temperatures, so you have to check if the solvent that maybe is not volatile under normal conditions will have such volatility under the conditions of operation. So that is really a complex thing. You must keep that in your mind. So in case you have such conditions and you apply temperatures, for example, for drying or for pressing, glue, yes, then you must check if you have organic substances that will be volatile and are solvents. So now we want to speak about where are the VOC emissions coming out by the adhesive coating. So I think it's clear that adhesives are used in a lot of important industrial applications in automotive sector, aerospace, and so on. I think modern adhesive coating plays an essential role in many, many things nowadays. So generally, we have always something like the preparation of a service, and then comes the assembling, and finally, it is the composite is cured or dried. There are different types of adhesives. I think it's not necessary now to go through, but you can, you will get all that information. Here is an example of an adhesive tape. You have a substrate. You have here something like a primer. And here the adhesive. And here's the silicone paper. And here, yes, the adhesive. So that tapes are very common in use. That's an example. And here, for example, a lot of different VOCs are used. For example, toluene or aliphatics or spirit. And depending from the type of adhesives, the solvent content, for example, can be around 70–60%. Additionally, impregnation agents can be used. Releasing agents play a role, and auxiliary materials like primers for the coupling are important too. Yes, here's an example how such a tape is produced. You have a unwinding system, and here the roller coating takes place. After that, you will, the tape will be cured in a dryer, and then you have a cooling station. For the VOC emission, please keep in mind, it's not only now that application and the drying relevant. Additional process can play a role, like the storage of the adhesives, the mixing, for example, if you do a thinning of the adhesives, the preparation for ready to make them ready to use. Yes, so and the cleaning, of course, of machine parts and the equipment. So that's a typical large installation that will fall under the Annex 1 of the IED. That means we have an IPPC installation. So that's a large installation, and especially from the drying, because you're using temperatures, you will have a lot of VOC that you must clean. So, by the way, here you see, if you have a rather closed or encapsulated machine, then it makes a lot of sense to extract the waste gases and to clean them. In other words, it makes sense to operate a waste gas abatement technique. But if you work more in an open area, where, for example, where you have spray application or other type of applications, and where it's more open everything, it is better if you reduce the emissions by a reduction scheme. Yes, here an example too. You produce here your tape. From here, you operate here an active carbon filter, or maybe you operate thermal oxidizer as a waste gas abatement. And at the end, you have here in your stacks only a few emissions. But that means that you collect the VOCs on all places where they originate directly, to concentrate the waste gas as high as you can. And so you will not have relevant fugitive emissions. So that's the approach. Yeah. Here, very similar. You have this, for example, here maybe you have some fugitive emissions where you do that application. Here then you have this drying system, and you extract the waste gas, the VOC containing waste gas, to your waste gas abatement. And here at the outlet, maybe you have some fugitive emissions, but at the end, all is here encapsulated. That means you will collect almost all VOCs. Besides, maybe here some small quantities that will be released at the in and outlet of the machine. Yes, for that you can use active carbon especially if you work with only one type of solvent. Then it can be very useful, for example, with toluene as a solvent, to recover it and to reuse the solvent. So what types of applicators are used for adhesive coating? So we have the normal air atomized spray methods. different methods. We have hot melt sprays. We have high volume, low pressure spray pistols. We can use dip coating, flow coating, or brushes or rollers, and hand applications. Extrusion is possible. So, or here, knife applications. So different systems, like here, a hot melt spray we can use. And depending on the way or the type of application, we will have what we call high effect on the overspray or not. For another way, for example, if you have a more spraying techniques, you have a larger overspray, because not all will match or will get to the surface. Some of the particles and materials will be lost. So the efficiency of the material transfer is not so high. For example, if you use something like a dip coating process or that knife application, or here that rolling application. So now we come to a very important point, because we need it from several reasons: the solvent mass balance. What does it mean? Solvent mass balance means what you put in as a solvent, as a VOC, somehow must be the same what gets out. So that's the reason we have input and we have outputs. That solvent mass balance plays different roles. Important, as I told you, is we need it for the compliance check for the reduction scheme, and we need it as a compliance check for the fugitive emissions and total emission limit values. It is not a burden, believe me. It is a very useful tool. And I must say, if I compare this, what I'm explaining you now with, for example, for the large animal holders, I prepare now an inspection in the moment for a very large chicken farm that has over 140,000 chickens. And in the new BIT conclusions, it's important that nitrogen reduced food must be applied, and of course the inspectors must control that nitrogen reduced food application, and that is done by something like a mass balance too. It's very similar, but I must tell you, I feel completely yes, how can I say, overstressed if I compare that compliance check from that animal farm with the VOC check. I think that VOC check, what we are doing now, is much easier than the check of industrial chicken farm, if it complies with the N-reduced food balance. So yes, that's really a hard job. Okay, so when you start now, and maybe some of you are now want to start, it's important maybe you organize a team, because if you operate a larger installation or medium installation, it's always good maybe you work here in a team, because what you must do is first you must identify here the VOC activities. So that means you must familiarize yourself with such activities that are listed in the VOC decree and you do in your installation. And then if you have identified that activities, you must collect the data. That can be a demanding job. because spatially, when you have several VOC activities and you must differentiate the different use of materials, that can require a change of your, how can I say, data system. Okay, now you have maybe some data, then you analyze them. You must identify what is missing. Very often in the first run, you will see you have maybe safety data sheets, but the range of the VOC content is rather large, maybe 20 to 40%. So it's not accurate for you. That means you must contact your supplier and you must ask them specific on the VOC content according to the VOC decree, or you can say to the chapter 5 ID or solvents emission directive, doesn't matter. I think they will know because they have a lot of experience now. And what you need to is the content of solids. So both information are relevant for you, as precise as possible. Then you start to elaborate a solvent mass balance, and maybe in the first step you will see you have to do something. In other words, you have to elaborate an action plan. That means really you have to think about what is the best approach for you. What can you do finally to comply? That needs, you must think about the situation where you're working now, maybe what you want to work in the future. Maybe you want to modernize your installation. Maybe we'll use different markets. Maybe you want to work more green. So all this you have to take into account for a decision on what is the best way for compliance for you. Let's give you an example. You're producing plastic parts or with for some kitchens, for example, and the sides you want to glue together, and so you must think: do you want to stay on a VOC containing adhesive, or maybe it is better for your customer, for your advertisement, for the situation, to modernize and to apply, for example, a water-based adhesive or hot melt, probably. So this is something you have to take into in your mind, because it's not too easy to switch between both approaches: installation of a waste gas abatement or the use of low VOC materials. So what you see here are looking first very complex. Don't worry, it's not so complex. Not so complex like the animal farms. So first you have the solvent input. That is what you have purchased in 1 year and what you have used for your installation. If you have in your installation, for example, a distillation unit, and you get back the VOCs from your waste gas and you reuse it, for example, toluene, then this I2 is a solvent input for your installation. If you store the recycled materials in the 12-month period and you don't use, or you use it for another activity, then we call it O8. And you may subtract that O8 from that solvent input when you calculate the solvent consumption that you compare with the solvent threshold that is listed in the VOC decree. So what we have more? We have here, for example, waste gases that are collected and discharged to a waste gas abatement, and maybe it is destroyed because it's burned and incinerated. So it is O5. What is remaining? We call that cleaned stack emissions capture treated exhaust gas. And those that are not cleaned, that are captured untreated exhaust gases. And you remember that's the reason it's colored here yellow. We have to consider this as fugitive emissions here for adhesive coating. Then we have waste with VOC, but that is collected in container. That means it's closed. We have no fugitive emissions from that collected waste because it's in that containers. This covers. So, and this will be discharged by specialist waste companies. So we deal, or we call this O6, and it's not fugitive. So if you would sell, for example, if you have recycling, and you, for example, you recycle toluene from your waste gas, and you sell that toluene as a product to somebody, so that could be O7 because it's not fugitive. You sell it. The others are fugitive emissions. For example, if you have produced a tape and after the drying, not all rests of VOC are taken away during the curing process, then you store that roll with the tape in maybe in a working hall. And of course, the VOC that is included in the tape will try to escape as a fugitive emission. Generally, that O3 is not relevant. It doesn't play any important role. Yeah, we have here typical classic diffuse or fugitive emissions from doors, windows, openings. So that is, I think, very clear. If we would have VOC in wastewater, that part would be considered as fugitive emission too. So what we have to do first, we have to calculate the solvent consumption. Generally, to make it simple, it is generally the solvent input. So to do this, it's useful to use a system, to have a database. Very often you have only the volume, then you must use the density to calculate the mass because we need the mass. Here's an example. You start, for example, have different materials, so you must really do an inventory at the beginning of a year. Then what maybe you have purchased, then you have to check what is existing at the end of the year. And you can calculate the total quantity, what you have really used. And if that is, if you have only, for example, in liter, you can calculate then the quantity by using the density. So that could be the way. Yeah, so you start with what you have at the beginning, what you have purchased, and you subtract from the end the storage stock quantities you have at the end of the year. Important is you must check, you need exactly this data, solid content and VOC content, what you see here. So you need really exact data from your supplier. And as a rule, very often you will not find such detailed data in the safety data sheets. So the safety data sheets are nice to have. You need them because to check and identify the hazardous organic volatile compounds like CMR. But you need, if it's not given in the safety data sheet, you need detailed values on the solid content and the VOC content. Here are some examples from glues. You see that is ethyl acetate, and I can see easily here it's flammable. So I know I must check then the vapor pressure. Yeah. So I show you now the procedure, how to do it. So you see, you have the safety data sheet. You check that has the vapor pressure that exceeds the 0.01 kilopascal. So I have here a volatile organic compound. Then you check the hazardous materials. If you find some, you see here the age statements, and that you compare with the given age statements for CMRs and halogenated organic compounds in the VOC decree. Here is another example, but the procedure is the same. Here, this company Fuller, is doing really, from my point, a good job, because here you see that values are very precise declared. So you see 100.0% is here VOC. And here you see exactly the different regulations. You see 100% VOC in percent. Here another example, but the procedure is the same, but again, that supplier declares the VOC content in a very precise way. So here it's easy. If you have such a safety data sheet, not necessary to ask the supplier, because he declared it really excellent. So the solvent input is very important because it's a large size and the largest quantity. So it must be very precise. That's important to keep in mind. I must jump a little bit. Here, when you need to calculate the VOC emissions for the whole year, you will find here that formula. Here is a problem, because normally the stack emissions are measured by what's called flame ionization detector, so that it measures the total, but referred on the total on total carbon, referred on the carbon molecules, but not on the whole molecule. So the carbon is something like the skeleton of the organic substance, but of course it's not the whole molecule. So you need to convert that measured total carbon concentration into the concentration on referring on the whole VOC molecules. That can be very complicated. So because you need that conversion factor, and you need the so-called response factor from the flame ionization detector. Normally, if you use the indirect method for calculation the fugitive emissions, it's not necessary to use to determine O1, 1.2. So of course you can calculate it very similar with the same method when you do here measurements, but it's not necessary when you apply the indirect method. But I will show you the indirect method in 1 minute. Important is if it's this quantity O5 that has some problems too, because O5 is not so easy to determine. Small uncertainties will have large consequences, but you will see. Very common is the method for the calculation of O5. If you do crude gas and clean gas measurements, and you determine the abatement efficiency of your abatement technique, and then you can use that formula. So the quantity O6 here, it can be relevant, but generally it's hopefully not so large because it's a waste. Please keep in mind, if you give your waste to a specialist waste company and they tell you, oh, we will do a distillation, it's okay, but for you, the waste is O6. It is not possible that you can subtract that VOC containing waste that maybe is distilled by another company. That quantity you subtract from the solvent consumption. Remember the solvent consumption, it has the formula I show you again. Here, and it was here, you can subtract 0.8, that is that quantity that has been recycled, recovered, but not been used in that installation from or that activity, VOC activity. So again, if you have VOC containing waste materials and you dispose them to a specialist waste company, and even they do a distillation process, but we can use this here because they generally do a mixture of distillation from other materials. So for you, it is O6. Here are some typical adhesive waste from the European waste catalog. Yes, it's not relevant for us. So I think I will explain you now this indirect method for the calculation of the fugitive emissions. We have here the fugitive emissions we start with the solvent input, what we have bought and put in, minus the stack emissions after a VOC waste gas abatement, minus what has been destroyed by that waste VOC abatement, and what was the waste, collected waste that we have disposed. The others here are, I would say, not relevant for the adhesive coating. And here I want to point out, if you write a little bit this term different, you will see if you make a bracket, you add here O11 and O5, and that's nothing else as the crude gas. So if you want to make it very precise, you can measure the VOC content in the crude gas. So that can be very useful, or it's the best possibility to get very precise values for the fugitive emissions. Yes, for the calculation, of the solvent, total solvent emission, we can do the same indirect method. We need that calculation for the solvent, total solvent emission, when we want to compare it with the reduction scheme with this target value. So when we do this, the total emission is the sum of the fugitive emissions and, of course, the stack emissions. When we put in now the formula, you see at the end we will have only the solvent input minus 0.5, minus 0.6, minus 0.7. But if you keep in mind, as I told you, for the reduction scheme, that the reduction scheme is based on no application of a VOC abutment. You can see 0.5 will be 0 for the application of reduction schemes, and 0.7 generally it's not, we will not have, and 0.8 we will have 0. So at the end it's very simple. It's the solvent input minus what is the VOC content in the collected VOC waste that has been disposed to specialist companies. The direct method, what is it? Here you do not do the subtractions. You add the fugitive output together, but you can understand then you have to do a lot of measurements and it's very complicated. So the direct method shows a lot of mistakes. I strongly recommend not to use this direct method. It is very hard to measure, for example, the room air in a precise way, or from my long time experience, I can say here we will always have a lot of problems when we apply the direct method. Only in very rare cases, like when for semiconductors and so on, very special rare cases, it can be applied. But generally, I recommend always this indirect method. Here, you find a lot of in that example a lot of explanations how to do the calculations. And I have here an example for you. We have a very large installation, and the first thing is you need to calculate this 0.11. There are some problems. Here you need the exhaust gas volume. You need the representative measured mass concentration. It was here 20 milligram. The operation hours and so on. You calculate then 0.11, but here you see the problem we have. It is on total carbon, because after such a thermal abatement, you do not know exactly what is the composition of the remaining clean gas. And in a worst case approach, we can use it just as a given as total carbon. So 0.12 is not necessary to calculate, because you will use the indirect method. We have to calculate what has been destroyed by the RTO. Here we need exactly to know the efficiency for the abatement, and so by application of this formula we will get that value. And when we do now the calculation, even it's based on total carbon, we see that the fugitive emissions are about something like here 12 tons. Now we compare it with the emission limit value. That is a percentage here, 20% of the total solvent input. So we have here about 242 tons. And we can, if we compare, so we see that that installation must be very encapsulated, and almost all VOC containing materials will be extracted and feed to the VOC waste gas up technique. Now, when we compare with the new BIT conclusions for tapes, you will see what I told you before. It is a total emission limit value. It is addressed on the percentage of the solvent input. So if we compare, we have a compliance here. So here you see from the new BIT conclusions, the values that are relevant now for such installations. Keep in mind that BIT conclusions were published in 2020. So for the EU member states, we have now 4 years after that publishing that all installation must comply with this new BIT IELs. In this you must keep in mind because this chapter 5 are only minimum requirements for the large industrial installations. In other words, if you have, if you're the operator or if you're an inspector and you have a large industrial emission directive installation, you must keep in mind that for that in IPPC installation, the BIT conclusions are relevant and not, let me say, the emission limit values from the chapter 5 IED. So here's another example where we want to apply a reduction scheme. So we know we have 600 tons solvent and 200 tons per solids. We calculate now that target emissions, that is 25% of the reference emission. For this reference emission, we use the solids with this factor that is given in the table in the VOC decree. We have just to look and find it easily. We calculate the target emission, that is a limit value. And now that operator see that he must do something. That's now the point what I try to express to you when I showed you this plan and act scheme. You will come when you start the first time, you will come to a point, maybe you're very happy because you see, oh, I am working in a very modern way and I comply with everything, and you can be happy. But if you, for example, here you see the operator has now to do a decision. And for that decision, you must consider a lot of things because it is a big change maybe for your installation and for your production process. Because if you change to water-based adhesives, that maybe is a possibility where you can solve the problem. Here's another example. So that's a way where you calculate the reduction scheme. That is already clear. But 1 minute on the problems. If you operate our waste gas abatement system, you see that calculation of the 011 is not so easy. You will have to spend a lot of effort on this to get this very accurate. and Z05 is rather complex too, because, for example, if you use that formula I showed you before with the abatement efficiency, what will happen? If 011 will be large, Z05 will increase too. In other words, if you use the indirect method, the fugitive emissions will drop down. So when you use the total carbon, as I've shown you before, and you have a compliance with the fugitive emission, you see you have used a worst case method, because when you use a conversion factor from total carbon to the molecules, of course, 011 will increase, and automatically 05 will increase too. Because you subtract it from the input, of course, the fugitives will be lowered. I hope this is clear. So for a first approach, you can start really with the total carbon, as I've shown you. There are additional problems, but maybe that is now not the time. It will take too much time, but later you will get this presentation and you see on the examples where the problems are. I will show you maybe my advice to solve that problems. I would propose, if you decide to work with waste gas abatement and it is a destruction of the VOC, like thermal incineration or regenerative thermal oxidizer or catalytic oxidizer, just start, as I have shown you, with 011 and 05 with total carbon. You can start with a conservative degree of the destruction efficiency. Yes, but if you don't find compliance, then you must be more precise. That means you must check the abatement efficiency. Maybe you have to do measurements over some days or a longer period, or yes, to get a most accurate abatement efficiency. That could be one possibility. Or for very large installations, and where you are really, you cannot say if you comply or not, such cases exist. The most accurate method is if you do a measurement in the crude gas together with a volume flow device and together with operating hours of the VOC waste gas abatement. And then you your computer can calculate exactly that crude gas mass flow or quantity. And if you know then the conversion factor, you will get a very precise value, and you can determine the VOC emissions or total emissions very accurate. So that are typical lamination machines. You see what I said before, you have sheets, not sheets, you have webs areas where you laminate. That means you glue together finally to get composites, but more now in detail. You see, there's a different activity that is called wood and plastic lamination. And the activity is described to adhere together wood and or plastic together. The threshold here is 5 tons. And please keep in mind, if you have cleaning of the equipment, all the VOC content of the cleaner you must take into account for that activity. So that lamination takes place when you have 2 or more layers and you glue them together to have a laminate or composite. In other words, normally it is the production of flat sheets. What materials are concerned? So if you laminate wood and wood, that is one option. What is regulated under that activity. But plastic, and that's much more common. So if you have plastic layers or foils and you glue them together, as you could see in that machine, I think that's very nice to see. That is, for example, the lamination of plastic. If you would laminate wood and plastic, that would be covered by that activity too. So what sectors are concerned? That is the flexible packaging. That's very the most common. Or wood processing, like the production of laminates for the parquet flooring or furniture, maybe for some kitchen foils could be concerned. Normally, that lamination processes take place in specialized company or sometimes in sawmills or other wood processing industry. Now, here again, we have to differentiate what is included and what is not included. So not included, for example, is if you adhere aluminum foils and plastic foils together. So that is not included because aluminum is not a plastic and not a wood. As I told you before, but I want to point out again, if you have a printing activity and you do maybe in the final step a varnish or lamination, that lamination after that printing unit that is associated to the machine or to the printing process, that is not covered by this activity wood and plastic lamination. It is covered by the printing activity. And of course, the adhesive coating, what we have spoken before, is not here included. So the lamination of paper foils is not included because paper is a paper and not a plastic. Or paper foils with plastic is not included too. And the production of fiber reinforced plastic is generally not covered by such activity. So now when we look on the wood sector, if you look to the parquet flooring, laminates that are used for the flooring or for the furniture, normally such production processes don't use nowadays solvent-based adhesives. So in that cases, even it is an activity, more hot melts or low VOC materials are used. So lamination of wood does not play a big role in practice. Here are some examples of laminates for the flooring. But you can see from the supplier of the glues that the used glue is generally a low VOC material. And that's the reason that the threshold of 5 tons is not exceeded, and the activity is then not in the scope of the VOC decree. Here, for example, for the parquet manufacture, that could be a lamination process wood, but you see dispersion that are water-based materials and hot melt adhesives are used. Or here, for the kitchen, as I told you before, flat lamination, they use hot melts and dispersion that is based on water materials. So here are some examples. Now, again, the lamination is the bonding of 2 or more layers of webs. That means on areas, on So here is an example of typical composite and how that process is working. You have, for example, here one layer where the adhesive is already on, and here's the second layer, and then the gluing or the lamination process takes place by pressing, and that as a typical production. One important thing is what I wanted to tell you. I don't know if you have in Serbia. There are so-called wood-based panels, you know, for the kitchens, and they're very common in a lot of households and usual products. And for that, wood-based panels are produced in large companies. So-called fiber boards, for example. That production is now included in Annex 1 of the IPPC of the IED. That means it's an IPPC installation. And for such production processes, there is a specific best available techniques document. You see here on the right side. Here are some explanations from that best available techniques document. So it is, if you have such an installation, it's useful if you look to that document. So here it's the same. We check now this, the activity and the solvent consumption. The theme is the same. So we look what VOC activities we have on the site. Now we have identified, we have that wood plastic lamination. Now we must check if the 5 tons are exceeded. That story you know already with the hazardous compounds, but here we have a difference. You see, for that lamination process, we have now a total emission limit value. That is 30 grams VOC per cubic meter. You see that 30 grams are not are referred on total carbon. Here, the 30 gram are the total of VOC that are emitted. It's important later for our calculations. This total emission limit values include all VOC emissions of the activity. Really, that means from the paint mixing, from the glue mixing, I mean, from the cleaning operation processes and so on. So for all VOCs that are used and applied for that activity. Here you see the limit value again. Maybe just to see, in Germany, we have reduced that value because that value is rather high. So we reduced that value on 5 grams per square meter. Last time I was asked to speak a little about, there were some problems with some installations because of order. Yes, it's clear. If you, for example, you see, this is something like a mean value over the whole year. I will explain you why, because the compliance check is done by the annual solvent mass balance. So for some processes, the operator can apply glues with a very high VOC content, and later maybe he is using hot melts. And finally, he will comply to the 30 grams per square meter. But in that time, where the operator is using materials with a high VOC content, maybe you have a smell in the neighborhood. And then you will see, you as an inspector, you have, it's really hard. If you have no other legal instruments, you are lost. In Germany, we have some additional legal instruments, like how we have to assess odor problems. We have something like a guideline with that is based on frequencies on odor, where you realize a smell. Let me say like that. So we have at the end a little bit the possibility to do something. But if you don't have such a tool, and you have only 30 grams per square meter, probably as an inspector you are lost. And that is what was one of the answers I gave last time, because it's very strongly depending how you design your legislation. And when I did my first cooperation with Serbia and with you, with some of you of inspectors, probably some of you know me, we discussed already such problems. But the point is, to find a solution is that you must lower probably such limit values, because with 30 grams per square meter, as I told you, maybe it works, maybe it works not, and depending how far the neighborhood is away. But that's the point. Okay, here for the total emissions, we have really calculate the fugitive emissions plus stack emissions. So one question sometimes always is coming, is it possible to use a reduction scheme with installations that comply with have to comply with the total emission limit value? And it's clear, if you have a total emission limit value, you have all the flexibilities of the world to comply with that value. So for such installation, a reduction scheme is not appropriate. It's not possible. It makes no sense, because the total emission limit value in practice is a reduction scheme, because you can do and combine all measures to reduce the VOC emissions, whatever you like. But you must show the compliance every year by the annual solvent mass balance. Here you can use a simplified verification too, because you should find in the VOC decree for that wood and plastic lamination an obligation. That means if the operator uses only here adhesives and primers, both, that have less than 5% of VOC content, and the operator declares this to the competent authority, then that's exactly the meaning of the simplified verification. Then for the operators, the job is done. But of course, the operators are obliged to comply with that material. So it's not possible if you get a new job or a new work where you need maybe an adhesive with a higher VOC content. It's not possible because that declaration has a binding function. So you cannot switch one time to higher VOC content adhesives and later you change back to low VOC adhesives. It's not possible. That means every adhesive must have that you're using, it's not an average, every adhesive and primer you're applying must be below 5% VOC. I hope this is clear. So yes, this you know already, but typical adhesives are ethyl acetate or methyl ethyl ketone or acetone. Here are some typical examples how it works. And I want to point out for the surface lamination, really nowadays in 2022, there are so many low VOC materials, especially for the lamination, available. So normally it should be possible to replace VOC containing lamination glues. You see now where are the emission sources? So here we have one emission sources when you apply the adhesive. So example, one foil is coming here, then the second foil is coming there. Maybe here additional primer or something else is applied, and here at the end you have the highest VOCs by the drying process. So yes, that are typical different ways how to do this lamination. So for example, here you have only one foil where you do this adhesive application, and then later you press by this combination roller, you press both together, and here you have then the lamination. Yes, it's here again when we want to speak about the emissions. So you have always the emissions at the adhesive where you do put on the adhesives, and when doing the drying process. Here you see that is typical machines. Now, depending on the type of machine, you see that it's very encapsulated. Depending on the type of the adhesives you're using, if you use, let me say, water-based or hot melt or what else that contain low VOC, maybe it's not necessary that you need a Batman technique or extraction process, depending on the temperatures that you're using. And but if you use VOC, classic VOC glues, then it's rather sure you must collect all voice gases, and then you generally operate a thermal oxidizer. That is very common. Yeah, and you need then to calculate the total emissions and must show compliance. If we now do the determination of the total emissions, what is relevant? If we operate a voice gas abatement based on thermal oxidation, like that destroys the VOCs, O5 is relevant, remember, and use the indirect method. The solvent input, of course, is important, and O6. But if you don't have, you see the same what I said before, you have I1 minus O6. You remember the total emission limit value refers on square meter. So you must calculate the total emissions, but you must then determine the laminated square meters. That means that is that area where you have put the glue on. So that is a way to do the compliance check. Yeah, so this is what I have shown in Germany. Here's an example. You see adhesive and primer is used in that installation. We have no waste gas abatement. Now we do the calculations. We do we calculate now the solvent input minus here we don't have any waste gas abatement, 0. So minus what is waste, VOC in the waste, and we know the total laminated area, and we divide the total emission by the total laminated area, and you see 36 grams per square meter. That means we have no compliance, and now that's a good thing. It's like you have now the possibility to think what is the best for you to reduce the emissions. That means maybe you can replace the primer by less VOC containing primer, or you play with the adhesive. Maybe you can make now hot melt, and so if you replace it, you can be sure that you will have a compliance. Now, best available techniques, I've spoken already on that. Here for the lamination, the use is really of VOC-free or low VOC materials. You will find a lot of supplier of total solvent-free laminators. So this is existing on the market. So it's not only one laminator that works solvent-free, there are a lot. Or what is very common now, the use of UV coating processes, especially for the flexible packaging industry. Here you can use so-called 100% adhesives. That means they don't have any VOCs in the coating. You see, you can produce solvent-free films. So there's has been made a big progress on low VOC materials. So here's an example again of it. So additional lamination station. And here are some examples of solvent-free laminated composite films. Or for example, even for more complex laminated parts, like here for the windows profiles, you can use polyurethane hot melt. You can use VOC reduced primers. Here is an example of a very famous company who is selling such glues. Yeah, and here you see how it works. And you can see the different possibilities. You see 98% VOC in the primer. Here, only 29%. So, and if you decide to work on with VOC containing materials, and you need a VOC waste gas abatement, here is an example for regenerative oxidizer, where you see from the laminating machines, all the high concentrated VOCs here, 8 to 12 gram, are extracted because the laminating machines are very closed, you will encapsulate it, and so you have a very high concentration, and you feed them to a regenerative oxidizer, and you will comply very easily with the limits, for sure. I think the time now for adhesive coating is really the use of low or VOC-free adhesives. A lot of effort has been done by the manufacturers of such materials. And if you have a look to, it doesn't matter where you look, if you look at German or normally there are always global players. If you look to manufacturers of adhesives, you will find so many solutions, very often in combination with manufacturers of machines that are based on low or VOC-free adhesive coatings and cleaners. So that's, I would say, the best way. If it's not possible, so then what is the next possibility is you must try to encapsulate or to, yes, to collect your waste gases at the source of origin as best as possible, and then you must try to have a very high concentrated VOC crude gas concentration that you can feed to a waste gas abatement technique. And what's the best waste gas abatement technique is depending on your need and what you're doing. If you have only one solvent as a solvent in your adhesives, like toluene, maybe it's useful to use an active carbon filter, because then you can maybe recover the toluene and you can use it again. So, but that is depending what you're doing. And if you have a mixture of VOCs or solvents, then maybe the recovery makes no sense, because what will you do with a mixture of the different solvents? Maybe you can use it for cleaning purposes, yes, maybe, but otherwise you have to give it away in large quantities as a VOC waste to specialist companies. So if you operate a waste gas abatement, it is not just you buy such an unit. You must maybe think about the way you are processing. That means maybe it's possible to automatize your gluing process by using, for example, a robot, or by using, for example, a dipping system. So there are different possibilities maybe to operate in a more and better material efficient way, and that will save materials, will save your money, and it gives you a chance by extraction of the machines to apply a VOC abatement technique. as I told you before, here you see that very important now BIT conclusions for service or treatment, service treatment installations with organic solvents. So here, for example, you find BIT conclusions for adhesive tapes, but not for adhesive coating, because such installations are not so big. They identified that only that the production of adhesive tapes included as BIT conclusions. However, it's clear the adhesive tapes manufacturing is something like the BIT coating, if we think now on the chapter 5 of IED. Yes, here you see a lot of techniques are listed in this best available techniques document. I will try to make it easier here. So even for the production of tapes, hot melts or water-based adhesives are possible, or UV curing adhesives are possible too. But for some maybe applications where you need high stress resistance, you will use further on solvent-based adhesives, and then you need exhaust gas abatement. Here are some examples now, not for that only for the tapes. I just only want to show you, you find really a lot of suppliers for hot melt adhesives with a wide range of application. The same is for dispersion adhesives that are based with water. Here is a so big market, unbelievable. Yes, for example, that company, you see how important now the use of so-called green adhesives is. That are not only adhesives that are reduced on solvents, but for example, they are reduced on monomers. Many adhesives are based on polyurethane, have that hazardous isocyanate inside as a monomer, and that is very toxic and very strict regulated, especially in America. So the suppliers or manufacturers of so-called green adhesives try to replace such hazardous materials. So now I come to a very important point too. If you reduce the VOC content of your materials, you have several advantages. Here, you save the occupational health of your workers, because these isocyanates are really critical, and if they are not included anymore as a monomer, that's a benefit for your workers. And additional, many VOCs are flammable. That means you have a risk on incineration in your installation, and so you can reduce the risks for the plant safety too by using, for example, water-based or other low VOC materials. So it is not only a benefit on the ambient air, it has different benefits. And again, when you do the solvent mass balance, I'm absolutely sure you will identify lacks, or let me say problems where are useful for you to solve that problem, because then you can maybe modernize or improve your production process. Finally, it will help you to work in a very efficient way. And so we all should consider the solvent mass balance as a benefit. Yes, for example, UV coating systems, I have told you already, there are a lot of even UV curable acrylic hot melts and so on. I told you already there are different application systems, and the application, for example, by rolling are more efficient for the material efficiency if you would do atomized spray methods. And if you want to use atomized spray techniques, and you use this high volume, low pressure technique, because as you can see here from that picture, this material efficiency is higher as compared to a normal pressurized air pistol. Yes, the robot application or machine application are very useful elements to improve your material transfer efficiency too. And especially if you work with VOC containing materials, if you work with robots or in machines, you have a very high concentration of VOCs. You can extract them, and you can do the machines enclosed, and so you reduce the fugitive emissions, and the other extracted emissions you can abate in an appropriate way. Yes, the good housekeeping is very important, to check everything. If you have spillages, to use, if they're possible, tubes and so on. So here you find a lot of examples. Sorry, I must look a little bit on the time. Here are now the best available techniques or TIL conclusions for the tapes production. You see, the operator can use the total emission limit value that is referred on the solvent input as a percentage, but the operator can decide on the application of a combination of here stack emissions. Here there's a difference because yes, here the operator must comply to the stack emissions here for additionally. So that are the best available techniques for the very large installations. Normally, I don't know a situation in Serbia. I don't know if you have installations that produce adhesive tapes and have more than 200 tons per year solvent consumption. Yes, that are the best techniques for abatement. Generally, here active carbon filters are applied, or thermal oxidizers or catalytic oxidizers. Here are some examples, additional examples where thermal oxidizers are applied for adhesive coating machines. Yes, here is an example for a catalytic installation where a catalytic oxidizer is used to reduce the VOC emissions from an adhesive coating installation.